All right, so today's video is 3.1 GCF factoring. So factoring out the greatest common factor. GCF stands for greatest common factor. Before we do that, I want to remind you of one other thing. So prime factorizations. Remember that the prime numbers are 2, 3, 5, 7, 11, 13, 17, and on the list goes forever. And when we are asked to do a prime factorization of a number, say we want to do the prime factorization of 24, that means to write 24 as a product of primes. We did this when we were simplifying radicals. And remember the process was we take the 24 and we find a prime that will divide into it. Well, it's even, so 2 will divide into it. 24 divided by 2 is 12. And then I look at the 12 and I see I can divide out another 2. 12 divided by 2 is 6. I look at the 6, it's still even, so I can divide out another 2. And then 6 divided by 2 is 3. Once I have a prime right there, the process is finished, and I can write 24 as 2 times 2 times 2 times 3. 8 times 3 is 24. Okay, now let's dive into the rest of the notes. So 3.1 GCF factoring. The greatest common factor, or GCF, of 2 or more integers is the largest integer that is a factor of all the integers. In other words, the GCF is the largest integer that will divide evenly into each of the integers you're working with. So for example, let's look at this example right here. If I wanted to find the GCF of 24 and 60, I'm looking for the biggest number, the biggest whole number that will divide into both 24 and 60. So I will find a prime factorization for the 24 and the 60. So the 24 we just did. The 60, if you do a prime factorization of 60, you can divide it by 2 and get 30, and then just go through the rest of the process. I can divide by 2 again and get 15, and then 15 is 3 times 5. So I get 60 is 2 times 2 times 3 times 5. Right? So pretty easy. The GCF is what they have in common. So notice they both have a 2. So they have that 2 in common. They have a second 2 in common. This one has a 2, but the 60 doesn't have a third 2. So they don't have a third 2 in common. They do have a 3 in common. The greatest common factor then is the product of those common factors. So 2 times 2 times 3, which is a 12. So the largest number that will divide evenly into 24 and 60 is 12. If you are trying to find the GCF of monomials, 2 or more monomials, you look for the GCF of the coefficients, and then you look for the common variable factors, and you multiply those. So for example, if I wanted to find the GCF of 6x to the third y and 8x squared y squared, I will look at those in factored form. 6x to the third y is 2 times 3 times x to the third is x times x times x, and then I have an extra y. 8x squared y squared is, well, 8 is 2 times 2 times 2, and then x squared we have x times x, and y squared we have y times y. So then we look for what they have in common. They have a 2 in common, and that's the greatest common factor for the coefficients. 6 and 8 are divisible by 2, but nothing bigger. We have an x in common. We have a second x in common. We don't have a third one, but then we have a y in common. So the GCF is going to be, notice what we have, 2 and then x, x, y. So 2x squared y is our greatest common factor. Okay, let's dive into some examples where we have to go through the whole process. We have this example to help us out as well. Okay, so to find the greatest common factor for each of the following. So we have 45, 81, and 117, for example 1. So what we're going to do is we're going to take the 45 and we're going to find its prime factorization. So I'm going to take that 45, and I know it's divisible by 5. 45 divided by 5 is 9, and then 9 is 3 times 3. So 45 is 3 times 3 times 5. It's that product of primes. Okay, the 81, we're going to do the same kind of thing. 81 is not even, so I can't divide it by 2, but I'll try a 3. Yep, 81 divided by 3 is 27. I can get another 3. 27 divided by 3 is 9. And then 3 goes into 9 and leaves me with a 3. So 81 is 3 times 3 times 3 times 3, or 3 to the 4th power. We'll just leave it that way. 117. Let's look at the 117. So for the 117, I need to break that down as a product of primes. I'm going to try dividing it by 3. 117 divided by 3 is, it does work, it's 39. 39 is divisible by 3. 39 divided by 3 is 13. And 13 is a prime. So I'm finished at this point with my prime factorization for 117. There it is. Now look and see what they have in common. We have a 3 times a 3. So the GCF, look what they have in common. 3 times 3, or 9. So our GCF is 9. Example 2. This time we have 4 monomials. We have 24x to the 3rd, 56x to the 7th, 4x to the 8th, and 12x squared. So I'm going to take each of these, and I'm going to write them in their factored form. So the 24, we already have its prime factorization up above. It's 2 times 2 times 2 times 3. And then x to the 3rd is 3 x's multiplying. 56x to the 7th. Okay, well, I'm going to do this one really fast. 56 is 8 times 7, and 8 is 2 times 2 times 2. Or you can use the factor chart, right? You can go off to the side somewhere and do a factor chart. 2 and 28, and then keep going. And the x to the 7th, 1, 2, 3, 4, 5, 6, 7. That's x to the 7th, product of 7 x's. 4x to the 8th. As you do these problems, I want you to look for little shortcuts. 4 is 2 times 2, and x to the 8th is 2, 4, 6, 8 x's. And then the 12x squared. 12 is 2 times 2 times 3, and x squared is x times x. Okay? What do we have in common? We have 2 and 2. Look, everybody has a pair of 2s. So we've got 4. Look, we don't have anything more because the 4x to the 8th doesn't have another factor to give. So the GCF for the coefficients is a 4. And then how many factors of x do they have in common? Well, 2. Everybody has 2, right? So our GCF for this one is going to be 2 times 2, and then x times x. Or in other words, 4x squared is our GCF. And that is example 2. Now, what does it mean to factor? To factor means to write something as a product. Write it as multiplication. So as we go through this unit, remember that when we are factoring something, we are writing it as a product. That's what it means to factor, to write as a product. For instance, up here, when we were doing 45, we were doing a prime factorization. To factor, it means to write it as a product of primes, right? Prime factorization, write it as a product. All right, let's dive into the last part of the notes. So here we go. Factor out the greatest common factor. If the leading coefficient is negative, we want you to factor out a negative. If the polynomial cannot be factored, we write that it's prime. So we have an example here in our notes that's worked out. It's 6x to the 5th minus 8x to the 3rd plus 4x squared, and we're going to factor out the greatest common factor. Now remember, to factor, it means to write it as a product. So factor out the greatest common factor. So here's what we have. We have to find the greatest common factor. So we found the greatest common factor, and the work is off to the side here. Greatest common factor is 2x squared. And then when you're factoring out a GCF, you are essentially undoing the distributing property. When you're distributing, you multiply it through a parentheses. When we undistribute or factor out a GCF, we divide it out of each term. So we find the GCF, which is 2x squared, and we write down that GCF. So we take the three terms, 1, 2, 3 terms. We find the GCF for each of them. That process is over here. We've got a 2, and we've got a pair of x's. So our GCF is 2x squared. We write down that GCF, 2x squared, and then we divide it out of each of the terms. When you're distributing, you multiply it in. When you are factoring out the GCF, you pull it out front and divide it out of each of the terms. Think about that. Okay, so I divide each of the terms by a 2x squared. 6 divided by 2 is 3, and then x to the 5th divided by x squared is x to the 3rd. That's where this comes from. Okay, the 8x to the 3rd, that second term, divide it by 2x squared. 8 divided by 2 is 4, and x to the 3rd divided by x squared is an x. That's where this one comes from. And then finally right here, 4x squared divided by 2x squared. The x squared's reduced to a 1, and 4 divided by 2 is 2. That's where this one comes from. And that's the process. So let's go through some examples. Okay, example 4. First step is find your GCF. So I need you to look at the two terms. We have y squared, which is y times y, and we have 2y, which is just 2 times y. What do they have in common? They have a factor of y in common. So our GCF is y. We bring the y out to the front, and then we factor out or take away a factor of y. What's y squared? If we take out one of the y's, we have a y left over. Or you can do it this way, y squared divided by y, which is just y. And then when we have 2y, this piece right here, we factor out or divide out the y. There it is. There's a 2 left. Another way to look at it is, look at this term right here. If I take out the y, what's left is a 2. Think about that. And then let's do example 5. First thing you're going to do is find the GCF. So we've got 12z to the 5th and 36z to the 2nd. 36z squared. Well, I'm going to notice that 36 is 3 times 12. So the coefficients 12 and 36 are going to have a GCF of 12. The z to the 5th, that's 5 z's, but the z squared is only 2. What do they have in common? They have a 12 and a pair of z's. So our GCF can be 12z squared. We bring the 12z squared out to the front. Think about what you have left over. If you divide out a 12 and a z squared from this first term, what do we have left? We have a z to the 3rd. We divided out the 12. 12 divided by 12 is 1. We divide out 3 of the z's. That leaves 2 left over. We divided out 2. Sorry, we divided out 2 of them. That's 3 left over. Right? You can see what's left over right here. This is what's left over. So if you've written it out in this expanded form, you can see what's left over. Through z to the 3rd. If I look at the second piece, that right there, divide out of 12, there's a 3, but I've taken the z's both out. So it's just a 3. And you can check your answer by remultiplying or redistributing. If you distribute the 12z squared through the parentheses, you will get what we started with, 12z to the 5th plus 36z squared. Okay? So our answers, notice they were written as products. So look at example 4 and example 5. When we factor out a GCF, we are writing it as a product. Okay? Factor out the greatest common factor. Okay, example 6. Notice the coefficient here is a 4. I'm not even going to factor that as a 2 times 2 because I can see that the greatest common factor for the coefficients is just going to be a 1, but they have an x in common. So my GCF for this is going to be an x. They both have a factor of x. So I'm going to take the x, their GCF, I'm going to pull it out in the front. I'm undoing the distributive property, so I have to introduce the parentheses. So I pull that common factor, that greatest common factor, out to the front. There it is. And now I'm going to write my parentheses. So if I do 4x divided by 4, what's left is a 4. I've taken out the x. X squared divided by x is just x, right? Think about it. 4x divided by x is a 4. And x squared divided by x is an x. And this is our answer. We have factored out the greatest common factor, the GCF. Okay, example 7. 15x to the third. I'm going to look at that 15 as being 3 times 5. We've got 3 x's. And now I'm going to look at the second term in that polynomial. The second term has a y in it. The first one didn't. 9 is 3 times 3. And then we have how many x's? 1, 2, 3, 4, 5, and then a y. What do they have in common? They have a 3, and they have 3 x's. Each of them has 3 factors of x. So our GCF is going to be 3x to the third. We're going to take that 3x to the third. We're going to bring it out in front of a set of parentheses. We're undoing the distributive property. We're undistributing. So if I take the first term, my 15x to the third, and I divide out the 3x to the third, when we distribute, we multiply it in. So we factor it out, we're dividing it out. 15 divided by 3 is 5, and the x's are gone. X to the third divided by x to the third is 1. Hold on to the minus sign. So that shows us where the 5 came from. The 9x to the fifth y. I'm going to divide that by a 3 and an x to the third. Let me clean that up just a little bit. And the minus sign stayed in the middle. 9 divided by 3 is 3, and if I do x to the fifth divided by x to the third, that takes out 3 of the x's and leaves 2, but there's also a y there, and we're done. And you can check your answer by redistributing. Feel free to check answers here. If you redistribute the GCF, you should get back to where you started from. But the answer we're looking for is the original polynomial written as a product. To factor means to write it as a product. Okay, example 8. Notice 7 is a prime. And I have x's. And here I have y's, and here I have d's. Right, I don't have any variables factors in common because they're all different variables. And 7 and 12, no factors in common. 19 is a prime. This whole polynomial is a prime because my GCF is a 1. Coefficients 7, 12, and 19 don't have any common factors other than 1. And the variables are all different, so I don't have any common factors. We call this one a prime. Okay, no common factor other than 1. We call it a prime. All right, example 9. Okay, on number 9, we're going to practice with dividing out or factoring out a negative. See, that first coefficient is a -4, so we're going to factor out a negative. So when I do my GCF and I do my factoring, I'm going to actually pull out a negative. All right, so to find the GCF, first thing I'm going to do, I'm going to look at that 4, A6B4. Did you notice as we're going through here that we're always going to be pulling out the smallest power? Because that smallest was what they're going to have in common. So notice this one, 2 times 2. So 4 is 2 times 2. So let's do some shorter or some shortening on this one. 4 is 2 times 2. 8 is 2 times 2 times 2, but I only have a 2 here. So my GCF is going to have a 2, which is the greatest common factor for the coefficients. Okay. And then how many A's can I get? This one has 6, but that one has 3. Oh, that one only has 2, so all I can get is 2. That's what they have in common is 2 factors of A, because the last one only has 2. And then for the B's, the first one has 4, that one has 7, and that one has 5, so I've got a B to the 4th power. But I want to factor out the negative. So remember, if your first coefficient is negative, factor out the negative. So we're going to practice with that. So we're going to take out a negative 2. So we're going to take this polynomial, we're going to write down what it's equal to. What is that polynomial equal to? It's going to be negative 2a squared b to the 4th. And then we're going to divide each of those terms by a negative, a 2, an a squared, and a b to the 4th. So off to the side, if you want, you can do a little work. You're going to take that first one. Oops, that was an a to the 6th, b to the 4th. And we're dividing out a negative 2, an a squared, and a b to the 4th. What do we have left? Negative divided by negative is a positive. 4 divided by 2 is 2. And I have a to the 4th power. The b's are gone. B to the 4th divided by b to the 4th is 1. For the second one, I've got 8, a to the 3rd, b to the 7th, divided by, make that 3 a little more readable, negative 2a squared b to the 4th. I'm dividing my GCF out of each one. Positive 8 divided by negative 2 is negative 4. And then I have a to the 3rd divided by a squared, which is going to leave an a. B to the 7th divided by b to the 4th is b to the 3rd. And that part is finished. Okay. Last piece. Make that 3 more readable. We're going to take a minus 2a squared b to the 5th and divide by a negative 2a squared b to the 4th. Okay, so negative 2 divided by negative 2 is positive 1. So negative divided by negative turns into a positive. 2 divided by 2 is 1. A squared divided by a squared is 1. And all I have left over is a b. B to the 5th divided by b to the 4th. And we are finished. You can check your answer by redistributing. But that is it. That is our answer. To factor it means to write it as a product.